first thing I do with every word problem is panic. As soon as I'm done panicking, that's when I start the word problem. So I read it, I cry during my panic, and then I relax. I read it once, and I just try to digest whatever's happening. And then I read it again with the object of actually solving the problem. And that first read through just lets you kind of get a grasp of what's happening. Second time through, I'm highlighting things, I'm writing down information, I'm doing stuff like that. So this problem says, two friends share a paper route. Sheena can deliver the papers in 40 minutes. Jeff can cover the same route in 50 minutes. Yeah. Given the equation below, show the time it takes to work together to complete the route. Then, how long, to the nearest minute, does the paper route take if they work together? So, read it once. All I drew out of that information was that they're doing a paper route. And well, they can do it individually, or they can do it together. That's all I know. If I read it again, I'm going to try to get a little bit more information. If you were in my class last year, you had to build these equations, which is what made them so challenging. In 30-2, from what I can see, you never have to actually build the equation. It's always given to you on the diploma. It makes it much easier. But I'm just going to show you where things connect in case you ever get thrown a curveball and you have to make it. So, two friends share a paper route. Sheena can deliver it in 40 minutes. That's obviously important. So Sheena's delivery time by herself is 40 minutes. Sheena alone equals 40. Jeff can cover the same route in 50 minutes. Jeff alone is 50 minutes. If you look in your equation, they built that into the equation. There's your 40, so that's representing Sheena by herself. That's your 50, that's representing Jeff by himself. The rest of what this equation is, the number on top, the letter, T, is their time together. So that's how long it would have taken them to do it together. And the 1 over here equals 1 route done. That's how they built this equation. They said the time together divided by their individual time, and then the plus the other person's time together divided by the individual time would equal 1 route done. Because they're both doing a fraction of a route. I'm going to do this portion of the route, you're going to do that portion of the route, and then we'll be completed that whole portion together. Given the equation below, time together to complete the route, then how long to the nearest minute does the paper route take if they work together? They're asking you what this T is. So you have an equation here. They want to know how long it takes them to do it together. So what are you solving for? T. This is like everything we've done up till now. It's a rational expression. So if you have a rational expression and an equal sign, you want to get a common denominator. Right? Even if you were like so bad at word problems and you could not understand what just happened, take that thing, recognize what unit you're in, and just try solving it, and maybe that's the answer. Like, who knows, right? But at the end of the day, it's rational expressions. You're going to have to use the skills from 3.1 to 3.5. So let's get a common denominator for this thing. Remember that if something doesn't have a fraction, we give it a fraction. 200? Yeah, they both go to 200. So you want to find a common denominator between these two things. You want to find what they can both multiply into. 40 can multiply into 200. 50 can multiply into 200. So that's a lowest common multiple. So that's a perfect way to do it. Another way you could do it is you could just say times this one by 50, times this one by 40, times this one by 50, and by 40. And that would also work. Your number is going to be a lot bigger, but that would also work. So your way would work, multiply everything to become 200. Or my way would also work, which is just multiply this one by 50, top and bottom. Multiply this one by 40, top and bottom. multiply this one by 40 and by 50. Both methods are legit methods. Yours is better. Mine takes less thinking.
So on the top, if you going to times what's on
So, yeah, so I would have 50t over, I believe, 2,000 plus 40t divided by 2,000 equals 2,000 divided by 2,000. I went and got a common denominator by giving everything the 50 or the 40 or both, depending on what it was missing. Yeah, 340. Why did we get a common denominator? Because a common denominator and an equal sign means you can get rid of that common denominator. So all you have is 50t plus 40t equals 2,000. You can add those t's together to have 90t equals 2,000. And you can divide both sides by 90. And that'll tell you how long to the nearest minute it takes for them to complete the route together. Put in your calculator, 2,000 divided by 90, 22.2. Sort of. You don't really do this unit that much in third grade. So 22.2 minutes would be the time it takes them to do it together. That's what it asks. Given the equation below, show the time it takes them to work together to complete the road. Together, complete the road. And then the nearest minute. So the correct answer would be 22. So this is a numeric response question. 22.2 would not get you the right answer. 22 would get you the right answer. You have to round it. And we had to create the equations last time, which made it a lot more challenging. Yeah. We were never given equations in mathematics. In this class, it should always be good.
Honestly, this is just different. Like, I feel like I'm not doing anything.
Yeah, you feel like it's math again. Okay, boat questions. So, Jerome rows his boat 24 kilometers downstream and then back to where he began. When the average speed of the current is 22 kilometers an hour, Jerome can complete his entire trip in 9 hours. Given the equation below represents Jerome's journey, how fast is Jerome rowing his boat? So, read a question once. Jerome's rowing a boat. He went downstream, went upstream. That's all I got out of that thing. If I read it again, then I'm going to try to draw some information out of this. So, Jerome rows his boat 24 kilometers downstream. That's important. So, it's 24 kilometers long. And then back. So, he does it there and then back. So, he does it twice. And the average speed of the current, so if you're thinking about swimming or thinking about rowing a boat, you have a current that's either pushing into you or a current that's pushing behind you. It's either slowing you down or speeding you up. If you've never done swimming in a pool or never ridden a boat like that before, think of it as running into the wind or running with the wind at your back. Right? If I'm running outside and the wind's in my face, it's slowing me down. If I'm running and that wind's at my back, I can feel it like pushing me, right? Like you feel like you could just like fly at full speed. So that's what this is trying to describe. When the average speed of the current is 2 kilometers, so the current equals 2 kilometers an hour, Jerome can complete his trip in 9 hours. Given the equation below represents Jerome's journey, how fast is Jerome rowing his boat? Okay. The question then is how fast is the boat? X equals boat speed. That's what in your equation, just to break down what's happening. This first part, the 24 is how far he's going, x is the speed of his boat, why would I have plus 2 on the speed of my boat? That's the current pushing me. So this is my downstream. The other one, you're going to notice it's the same thing, but this is going to be your upstream. As you notice that the current is slowing you down on this one. The equal sign is the time that it took. So the blue circle is time downstream, plus green is the time upstream, equals your total amount of time. So if you were to have to set this thing out by yourself, maybe if they just gave you portions of this equation and you had to link them all together, time down plus time up would equal your total time. That's legitimate that you might just be given the 3 things separately and you have to combine them into one. That's a legitimate thing they could do. Alright, given all that information, how am I going to solve x? Here. Balance out the bottoms. You need a common denominator. The best way to get a common denominator is to put brackets around everything. Remember, those are packages. So you need to have the entire package in each denominator. The other thing I'm going to do is I'm going to make that 9 over 1 so that I remember that it's also a fraction I got to deal with. What's the first fraction missing on its bottom? It's missing an x minus 2. What's the second fraction missing? It's missing an x plus 2. And the 9 is missing both things. So you're going to have to do x minus 2 and x plus 2. This gives us, we should actually get in the habit of doing NPVs. Just a reminder that x cannot equal positive or negative 2. We should definitely do that. This is going to give us an equation that's quite long. We're going to have 24 x minus 2 plus 24 x plus 2 equals 9 x minus 2 x plus 2. I can cancel out all the denominators, so I'm not even going to waste my time writing them because they are now all the same. How am I going to solve that? That's a good question. So the first thing I'm going to do is what Jaden's alluding to, which is multiply everything together. Right? The only way you're going to solve these things is by expanding them and multiplying everything together and then moving them all to one side. Jaden's question is, what happens with this 9? Does it multiply into the x minus 2? Does it multiply into the x plus 2 and the x minus 2? Yeah, that's a good question. My advice is leave that to the end and multiply these 2 binomials together first, and then multiply the 9 in after. That'll make your life easier. If you want to do it the other way, you just multiply it into one. Not multiply.
And then you'd FOIL it after.
And then you'd have to FOIL your result after. That's why I suggest FOILing first, to make your life a little easier. So, the 24 is going to come in the brackets for both of those. The 9 is going to come in the brackets. Sorry, I haven't FOIL first. I haven't FOILed yet. So the x's are going to go in and the 2's will go in. So I'm going to get 24x minus 48 plus 24x plus 48 equals 9 on the outside still. We get x squared plus x squared minus. So if you were to multiply those 2 binomials together, that's what you would get. You get plus 2x minus 2x, they wipe each other out, and you have x squared minus 4. Now you multiply the 9 into the bracket. In the same step, I'm also going to combine my like terms on the left side. So that's going to give me 48x, and the 48's cancel each other out. So 48x equals 9x squared minus 4. And it wouldn't be 4, it'd be 36. On the other side of the equal sign, I multiplied the 9 into the brackets. So this 9 now comes into the brackets to make 9x squared minus 36. Is that the part you're talking about? Yeah. Now we get close to factoring. Before we can factor, we have to be in general form. So we got to subtract 48x from both sides. 0 equals 9x squared minus 48x minus 36. At that point, now you try to solve that thing. You could factor it, or you could use the quadratic formula. If you remember that from last year as well, you could just punch those numbers into a formula. I always prefer factoring. I'm always like factor, factor, factor. That's the way to do it. So you try to find a number that can divide into all three of those as a GCF. It's probably a good place to start. So a number that goes into all those. What does it say there?
I can not have it.
Oh, that's what I heard you say. Oh, Sierra said it.
Yeah.
A 3 can go into all those. So we get 3x squared minus, I think 16x, and then minus. Remember, when you're factoring, GCF goes first. Then you can try to diamond method this thing. When you diamond it, you're looking for things that also be negative 36. Add to the negative 16. Negative 2 and 18. Negative 18 and 2.
Yeah, I screwed up.
That means this thing's going to factor to become 0 equals 3. Then you're going to have 3x minus 18. 3x plus 2. You have to take a 3 out of one of them. 0 equals 3. X minus 6. 3x plus 2. Alright. It's a lot of mathing. That's what we just did. So, you set up your equation. You got a common denominator. You got rid of the denominator because there's an equal sign. You multiplied everything that needed to be multiplied so that you could move everything to one side because that's the only way to solve these things. Once everything was on one side, you factored it. It was a tough factoring question. You took out a GCF first, then you had some ugly numbers you had to deal with. If you did all of that without screwing up, you still don't have the right answer yet. So all of that just leads us to figuring out what the answer is. Why did we factor all that? So we could figure out what x value would work, right? Figure out the answer. The answer to this is what makes each set of brackets equal to 0. So what would make the first set of brackets equal to 0? 6. What would make the second set of brackets equal to 0? Negative 2 over 3. Remember, the trick is the number without the letter divided by the number with the letter. If those are your answers, if x equals 6 and x equals negative 2 over 3, and the question was, how fast is the boat going? Negative 2 over 3 does not make sense. So how fast is the boat going? It's going 6 kilometers per hour. That would be your final answer. So with word problems, sometimes you're going to get two answers, and you need to logically eliminate one of them. Because, like, you're right, if you put 2 over 3, negative 2 over 3, into the equation, it would work out. It actually would give you the right answer. But logically, there's no way that negative 2 over 3 is going in to that boat speed, and that's how fast it's going. That is probably as hard as it can get for word problems. The only thing they might change on you is that they wouldn't give you the equation built nicely together. They might break it up. So they might say, this is how long it takes to get upstream, and it's this equation. And this is how long it takes to get downstream, and they give you the equation. And its total is 9 hours. So you literally just have to connect the 3 dots. You won't have to build the whole thing. Okay. Here's a question. Is that on your page? I'm wondering how my example from another class is on this example. This is not an example for you guys. What? Very close. You saw it. Good.
Yeah.
Alright, let's skip that question because that straight up is not in your class, so it does not need to be done. Here's a question. I want you to try completely on your own. Okay, so this is one you should now be able to set up, do it on your own. Try your best at it. Okay, I'll put my work on the board so you can try to follow along. Okay, the lawnmower question. So we've got Alex and we've got his brother Frank, and they're cutting the grass together. They give you the equation. They tell you that the little brother can do it in 90 minutes. That's why 90 is on the bottom. And the older brother can do it in 45 minutes. Notice that they didn't say 90 minutes for Frank in the question. They said 1.5 hours in the question. So they have converted 1.5 into 90 minutes right here in the equation. You have to just be able to realize that's why they use the number 90.
Will we ever have to do that?
You shouldn't have to do it now. It's possible, unlikely. Then you just had to solve this equation. It's actually, you could do it logically. So some people are able to just figure out it's going to be double and single. I highly suggest to avoid trying to do it logically because they don't make the questions easy enough on the phone to do it logically. They do make them easy enough, though, that you could just get a common denominator of 90, cross out that denominator, collect like terms, and then get it by itself. So 30 minutes is the time it would take if they did it together. Alright, next one. This one is one you're going to have to do again on your own. This is probably a likely question for a diploma. Like, this is the standard you have to be able to reach. What I want to remind you before I set you off on your own journey is that when you're getting a common denominator, that is a package. And that entire package needs to be in everything. You can't just add 7 to every denominator. That's not how it works. You've got to do it through multiplication, and you have to have the whole package.
So on the way there was not a win against them? Like, as near that one?
There was a win against him and a win with him, but it just says with the tailwind, the average speed was 7 kilometers faster. So that's 7 kilometers faster than without the wind.
So it's not fast.
So you don't know the speed of the wind. Like the speed of the wind might have been 3.5.
Yeah, but what, like, for the second equation, we don't have to add
No.
-7?
No, the reason why is because then you would be 14 kilometers an hour difference.
Oh, okay.
It only told you were faster one way and never told you how much slower you were the other way. So it's just the same average speed. Okay. Yeah, I'll pause this. You guys. Okay. So you have this equation. To get the common denominator, you had to multiply by s plus 7 and by s to that number on the far right side. You also had to multiply the first one by s and the second one by s plus 7. You can cancel out all the denominators because you have an equal sign. Remember, and please don't get confused, you can only do that if there's an equal sign. So if there wasn't an equal sign, you have to leave the denominator. So when you're doing your assignments and your other questions, if it's just a basic adding, subtracting question, don't cancel out your denominator. You only do that if there's an equal sign. I then multiply everything together so that I can move everything to one side. The reason I move it to one side is because I have to be in general form. General form is ax squared x plus bx plus... The reason I have to be in general form is so you can factor. This question, you can't factor. And probably a sign that you couldn't factor was it said to the nearest tenth of a kilometer an hour. Usually means you're not going to get a good number when they ask you to round to a nearest decimal. So, to solve this thing, you try to factor, you can't. You have to use the quadratic formula. The quadratic formula is x equals negative b plus or minus b squared minus 4ac. Your quadratic formula is given to you on your diploma and on every test that you do starting now, because you'll start to need it soon. Yeah. So using the quadratic formula is a good question. What you're going to do is you're going to realize what all these a, b, c values are. That's how I like to do it. So I would say a equals 4, b equals negative 22, and c equals negative 175. And then I go back to my quadratic formula, and I replace every letter with brackets and then whatever the number is. The symbols all stay the same. Don't change the symbols. So I'm going to go x equals negative, and then I go bracket, and I put in whatever my b is, negative 22. So don't change the symbol, just change the letters. Plus, minus, root sign. B squared, negative 22 in brackets, squared. Minus 4 times a, which is 4, and c, which is negative 175. All divided by 2a. You'll notice every letter I replace, I used brackets. It's a good habit to get into. The next good habit to get into is do not try to punch that entire thing into my calculator at once. Instead, I punch just this part into my calculator first. And I also am going to calculate that part. So now it's going to become x equals 22 minusing a negative, would cancel out, plus or minus the square root, and I'm just putting that in my calculator, and I'm putting it the exact way it looks. What's it, 3,000? I'm putting it in the exact way it looks. So you have to use brackets around the negative 22. If you don't put brackets around the negative 22, it's not going to give you the same answer. That's important. Yeah, I got, punch that into because I see some confused looks. So, minus 3,284. 484? Are your negative 22 in brackets? Okay, I'll take a look after. Is your negative 175 in brackets?
Well, all I did was, okay, I got, no, like I
Did you square root it?
Not, like,
I'll come take a look.
okay.
I'll take a look. Okay. Divided by 8. What is 2 times 4 is the first sheet. All I did, that thing I underlined in red,
Put that
exact thing. Just the stuff I underlined, not the square root sign. Literally put brackets, everything the exact same, and your calculator can do it. If you mess around and try doing something else, then it might pop out something.
Okay.
Beautiful. Okay, at that stage, that's what I'm willing to put in my calculator. So I'm willing to go 22 plus square root of 3284, hit enter, divided by 8, enter. And that's going to give me 1 decimal. Then I'm going to do it again, but with a subtraction instead. So this should give you 2 answers. What's the positive answer? It's a negative 1.
Negative 4.
This is if you do the plus symbol. This is if you do the minus symbol. Both answers are legitimate, so you have to test both ways. Then you have to use your brain to think if one of them makes sense or one of them doesn't make sense. Does one of these answers not make sense? The negative answer makes no sense. We're talking about somebody racing. They're not going to go negative 4.4 kilometers in a race. Yeah, they're not doing a good job in that race. Not Mario Kart. So this thing, what's your final answer? 9.9. Just 9.9.
But on like if that was a numeric response, would your answer be 10.0?
No, it would be 9.9 because it says nearest 10. of a kilometer. You only round once. So you round the 1
You round
into the 9.
up.
Yeah. So the correct answer would be 9.9 if it was numeric response. All right. Last one.
This one is another question from 20.
Yeah, straight up a quick